Hey guys, here is a summary of the whole of algebra for your GCSE maths. Now, as you're going through this, use either your revision guide or the free revision guide over on our website to go through, check which bits you don't know, check which bits you do know, and then fix the bits that you don't know. Go and find the individual videos and fill in any gaps that you have. Now, there's only one video. I haven't done separate videos for each of the examples because the specifications are so similar. The good thing about this is it means you can use other exam boards, specimen papers, past papers to help you revise. And the only thing that will get you a top grade in maths is practice, 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 practice. Good luck, guys. Sometimes in maths, writing things out fully can be really tedious. So there are a few conventions that we use to speed things up. You have to be able to recognise what they mean, and you have to be able to use them in algebra. So, x times y can be written as xy. We don't need to bother writing the times in. If we have x and x and x, again, that's writing out quite a lot of things. We just have 3 x's. X times x, we can write as x squared, and then if we want to have x divided by y, we can just write that as x over y. You need to be able to put terms into an algebraic expression. So here we have 2x plus 3 and x equals 4. So what we need to do is replace the x with 4, so that is 2 times 4 plus 3 equals 8. Plus 3 gives us 11. You need to be able to collect like terms in an algebraic expression, and for this what I suggest you do is either rewrite things in order or get your highlighters out and start highlighting. So we have x's, things with x in, things with x in, things with y in, things with y in, things with y in. Now we can rewrite this as x plus 2x plus 3x. Altogether that makes 6x plus 1, 2, 3 y's. I can multiply a number in front of our bracket, so here is our 2 in front of our bracket. We need to times it in by everything inside the bracket to get rid of the brackets. So we have 2 times x gives us 2x plus 2 times 4 gives us 8. Whenever you see a long, complicated algebraic expression, this one's quite simple, but you should always consider factorising it. To factorise it, you need to look at what both things have in common. So both the 3y and the 12 can be divided by 3, so we're going to put that outside. We're going to make some brackets. 3y divided by 3 is y. 12 divided by 3 is 4. I can multiply out 2 expressions. Now this is where things start to get a bit complicated, and I think it's really important that you draw your lines in. Even if you are like really good at this, please just draw your lines in, because in the exam you might get a little bit stretched, you might make a silly mistake that you wouldn't otherwise make. So please draw your lines in. There are 2 different ways of drawing your lines in. You can go 1, 2, 1, 2, or the way that I prefer to do it, just because it looks a little bit nicer, is like this, and then we can turn it into a smiley face. Now I know this is really trivial, but exams are stressful situations, so anything we can do to make it a little bit nicer, a little bit happier, a little bit less stressful is going to be a good thing. So there is my expression, and you can do this in whatever colour you like. We still have to multiply it out. The other thing I would like you to do is once you have finished doing a line, just cross it out so that you know you've done it, you don't repeat it. So first of all, I'm going to do this line here. That gives us x squared, and I'm going to cross out the line because I know that I've done it. Then I'm going to do this line here, 3 times 4. Then I'm going to cross out the line so that I know that I've done it. Then I'm going to do this one, 3 times x. Then I'm going to cross out the line so I know that I've done it. Then I'm going to do this one, x times 4. Then I'm going to cross out the line because I've done that one. Then you need to collect the terms together. So these two these two. Those two are the same, so we're going to need to put them together, and you need to sort things into the right order. So x squared plus 7x plus 12. Now, there are two different methods up here. This one will give you things in the right order, whereas the smiley face method won't give you things in the right order. You usually need to remember to put them in the right order. Factorising things that were in the form of x squared plus bx plus c. So for this one here, we need two numbers that multiply. And for this number here, we need two numbers that add. So the first thing you do is you write down your two open brackets. Since this is just x squared, we can pop that in already, x. Since both of these are plus, we can pop that in as well. Then we need to think of all the things that multiply to make 8. So we can have 1 and 8. We can have 2 and 4. I think that is everything. Now you need to look at your list of numbers. Can we use 1 and 8 in any way at all to make 6? No, we can't. Can we use 2 and 4 in any way at all to make 6? Yes, we can. 2 and 4. Sometimes your algebraic terms will be getting quite complicated, so you want to make things as simple as possible. And when simplifying an algebraic expression, you're going to need to collect like terms, you're going to need to factorise, you might need to deal with some brackets, expanding brackets in there. You also might have to deal with some fractions or some surds. Rearranging equations to make a different thing subject to the formula comes up so frequently and in so many different places. It's definitely one of the core skills I recommend you practice a lot. So here we are going to make y the subject of the formula. So first thing I'm going to do is to minus 6 from both sides. So we're going to get 8x plus 4 minus 6 plus 4 minus 6 is going to give us 8x minus 2 equals 2y. You can see y is currently times by 2, so I'm going to divide that by 2, giving us 8x minus 2 divided by 2 equals 2y divided by 2. You can see here I've got a 2 on top and bottom, so that's going to cancel. Here I've got numbers I can divide, so that is going to give me 4x minus 1 equals y. It does not matter that y is on this side of the equation. It's exactly the same as having it on this side, it just happens to be on the right hand side. Do not feel you have to minus 2y at any point to get y over here, and then minus 8x to get x over this side. It's perfectly okay to have y on the right hand side. Surds are another example where knowing your square numbers and your square roots especially is going to come in really, really handy. And surds are not scary. They're just a nice, easy, simple way of writing a long, horrible number. For example, square root 6 is much easier and more accurate than writing the number out in full. But you can just treat them like anything else in algebra. 2 square root 6 plus 2 square root 6, all we need to do is to add the numbers in front, just like adding 2x and 2x, and we're going to get 4 square root 6. Again, just like algebra, if you have 6 square root 6 divided by 2 square root 6, 6 divided by 2 is going to give us 3 square root 6. If we have square root of 2 times square root of 18, that is exactly the same as saying square root of 2 times 18. 2 times 18 is 36. The square root of 36 is 6. So I know they look awful, but they're really, really not, I promise. If we are multiplying terms, we need to add the indices. For example, x cubed times x to the 7, we need to add the indices, so 3 times 7 will give us x to the 10. If we are dividing terms, you need to subtract the indices. For example, x to the 6 divided by x to the 2, 6 minus 2 is 4, so it's going to give us x to the 4. Functions are another thing that look awful and scary but really aren't. So fx equals 3x plus 2, we need to answer if f is 3. So all you need to do, you'll notice here that x has been replaced by 3, so in here we need to replace x with 3. So that is going to give us 3 times 3 plus 2. 3 times 3 is 9, plus 2 equals 11. Coordinates are going to be in the format x and then y. So x and then y. And vectors, not relevant here, but kind of. So x on top and y on the bottom. So if you're plotting points, we need to go x first. So 2 across and then 4 up. So our first coordinate will be there, and we mark that with a nice cross with a sharp pencil. A blunt pencil is not going to do you any good in the exam. For our second set of coordinates, we go -1, -3, down there. Again, sharp pencil. If you are plotting a line from an expression, say y equals 2x plus 1, the simplest thing you can do is work out some points. So if y equals 1, so when x equals 1, y equals 2x plus 1. So when x equals 1, y equals 2 times 1, which is 2 plus 1, making that 3. When x equals 2, we have 2 times 4, 2 times 2, which is 4 plus 1, giving us 5. When x equals 3, it is 2 times 3, 6 plus 1, 7. We can now plot those points on our grid. And using a ruler, which I don't have, you can join the points up. When we're trying to find the gradient or the intercept of a straight line, we need to be thinking y equals mx plus c. M being the gradient and c being the intercept. So if we look at finding the gradient first, what you need to do with a pencil and a ruler is draw the biggest triangle that you can fit on. Bigger triangles are better because they are more accurate. So I'm going to go to there because it's a nice number. So we are going from 5 to -3, that gives us 8. Then we are going from 3 to -1, that gives us 4. So to find the gradient, it is up divided by a cross. So up we went 8, across we went 4, so 8 divided by 4 gives us a gradient of 2. And then c is just where it crosses the y-axis. It crosses the y-axis at -1. So our c is -1, giving us a total equation of y equals m, which is 2x, c, which is -1. If two lines in the format y equals mx plus c are parallel, they are going to have the same gradient, so the same m. So it doesn't matter where they cross the y line, if they have the same gradient, they will be parallel. For a quadratic graph, the roots are going to equal the x-intercept, and the x-intercept are going to be these points here on the x-axis. Turning point is going to be the coordinates of this point here. The graph for y equals x is going to go straight through the middle. Increasing a number in front of the x is going to make it steeper. Decreasing the number in front of the x is going to make it shallower. Putting a number after it is going to shift it either up or down. You need to recognise the shape of the graph for x squared, which is nicely like a big smiley face. Unfortunately, -x squared is like a sad face. Putting a larger number in front of the x squared, say 2x squared, squashes it. And a smaller number makes it expand outwards. X plus a value squared is going to shift it left by that value. X squared plus 3 is going to shift it up by that value. Here is the graph of y equals x cubed minus x cubed, 3x cubed with a large number in front of the x cubed, a third x cubed with a small number in front of the x cubed. X cubed plus a number will shift it up or down by that number. And x plus a number and then cubes will shift it left or right by that number. Here is the graph for 1 over x. The important things to remember when you're plotting a graph is that your points are accurate. A sharp pencil and a cross is the best way to accurately plot points. That they are clear, that you do not do a massive circle or a massive splodge, or your pencil's not sharp enough, so it's not exactly clear to the examiner whether you've plotted it on one box or another box. Your axis has to have a clear scale on it. The scale has to be in order, the scale has to make sense, it has to have a title, and it has to have units. And your line needs to be a smooth, curved line. This sort of line here is not going to get you any marks in the exam. Remember, this is maths, not arts. We need a smooth, strong, confident line and a line of best fit. Distance time and velocity time graphs look identical. The only difference is that one is labelled distance and one is labelled velocity or speed. And you have to be paying attention to the graph before you can answer the question, because even though they look the same, they're telling you very, very different things. So if we first look at this section here, on a distance time graph, this is going at a steady speed. The middle section here on a distance time graph, you'll see that as time is progressing, distance is not progressing. So this is staying still. Then the last section, they are also moving at a steady speed. But if we look at the slope or the gradient of the line, you'll see that this steady speed is slower than this steady speed here. If we look at a velocity time graph, the first part is acceleration. The middle part, where it's flat, so time is going across, velocity is not increasing, but velocity is not zero, so they are still moving. So this is now a steady speed. And then the last part is again acceleration. But if we again look at the slopes, you'll see the slope here is shallower, the gradient is shallower than this one, so it is accelerating less rapidly. If we want to solve two linear simultaneous equations from a graph, we need to be drawing the points on the graph, we need to be looking at where they cross over, and that is going to be the solution. If you have a linear and a quadratic equation, again, you need to draw them on the graph, and the points where they cross over, this is going to give you two solutions, is the answer. Here we have a quadratic equation that we need to solve by factorising. So we need to draw our brackets, x. You can see we have a plus and a minus, so they're not both pluses, we can't write that in at the moment. We need to look at numbers that multiply to make 4, and then add or subtract to make 3. So we can have 1 and 4, or we can have 2 and 2. But it's a bit more complicated than that because it's minus 4. So we can have minus 1 and plus 4, or we can have plus 1 and minus 4, minus 2 and plus 2. But they need to add in some way together to make 3. There's nothing we can do with 2 and 2, so we can't do that. It has to be plus 3, so minus 4 plus 1 is going to give us minus 3, so it's not that one. So it has to be this one here. So we are going to have plus 4 and minus 1. I've lost my brackets. Plus 4 and minus 1. Now we know this equals 0. Now if something to equal 0, two things times by each other to equal 0, one of these has to equal 0. So to make each bracket equal 0, x plus 4 equals 0. We need to rearrange that. So x is minus 4, or x minus 1 equals 0, which rearrange will give us x equals 1. So there are two solutions to a quadratic equation. By factorising, you have to put it into brackets and then make the brackets equal 0. Simultaneous equations can be solved in a large number of different ways. You need to find the way that works for you best, which you prefer, and then go with that one. Substitution, which is for no particular reason my preferred method, multiplication, addition, subtraction, or you can solve them graphically. Graphically is a bit more complicated, and unless they ask you to do it, don't generally do it that way. So I'm going to show you two different ways of solving the same equation, and hopefully we should come up with the same answer both different ways. So I'm going to call this equation number 1, I'm going to call this equation number 2, and I'm going to start with substitution. So I'm going to rearrange equation number 1 to make y the subject of the formula. So 2x plus y equals 7. Y equals 7 minus 2x. So now I know what y is, I can pop it into equation number 2. So 3x minus y equals 8. 3x minus y, which we know from previously, is 7 minus 2x equals 8. Multiply out the brackets. 3x minus 7 plus 2x equals 8. Tidy this up. So 3x plus 2x gives us 5x. 8 plus 7 gives us 15. 15 divided by 5, x equals 3. Now we know what x is, we can put that into either equation number 1 or equation number 2. I'm just going to pick equation number 1. 2x plus y equals 7. X equals 3, so 6 plus y equals 7. Rearrange that, so y equals 1. So that's doing it by substitution. I'm now going to do it by addition. Now, addition, subtraction and multiplication all go together, because if you want to have addition, you need to have something with the same number in front. So here I've got 1 and 1 in front of y, but different symbols. So if I add these together, they're going to cancel each other out. Subtraction would work if this was plus y and plus y. And if we didn't have any of the numbers the same here, we could multiply one of these equations. For example, we could multiply this one by 1.5 if we wanted to get x the same, so we could either add or subtract those. So those three work together. So I'm going to add the equations together. So 2x plus y equals 7. 3x minus y equals 8. Add them together gives me 5x minus y plus y gives me 0. 5x equals 15. Divide that out, x equals 3. Now that I know that x equals 3, I can pick either of the equations. Since I picked equation number 1 last time, I'm going to pick equation number 2 this time. So 3x minus y equals 8. X equals 3, so that's 9 minus y equals 8. Take 9 over to the other side, so we get minus y equals minus 1. Times that by minus 1, y equals 1. So you can see both methods give the correct answer. Both methods are valid. You just need to pick which method you prefer. The next part, making equations from a situation given in a text, can be tricky for some. When I'm working you through exam papers, I try and do this for you as much as I can, partly because maths makes more sense in my head than words does, and partly because you need to know how to do it for your exam. So Primrose went to the shop and she bought 4 biscuits and 1 sweet. This cost her $1.24. The next day she went to the shop again and bought 2 biscuits and 2 sweets. This time it cost her $1.99. How much does each sweet and biscuit cost? Now, on the face of it, this may look like it may look like an impossible question, but what I've done is I've taken the information as a text, I've written it down as 2 equations, and now I can solve it as a simple simultaneous equations question. Don't try and solve this, I literally just made it up, so I don't know whether there are actual answers to this, so please don't leave loads of comments about how I've done the equation wrong. Solving inequalities can scare people because of this big inequality here in the middle, but you can just treat it exactly the same way as you can an equals. So x plus 3 is greater than 7. Moving the 3 over to the other side, minusing 3 gives us x is greater than 4. Now we need to pop that on a number line. So we can draw an open circle at 4, because open circle shows that it's greater than, if it was greater than or equal to. If it had this symbol, we would do filled in circle, but it's just greater than, and then we are going to go this way. Now, there are a few things you need to be aware of when you're solving inequalities. The sign does not change direction if you add or subtract numbers or if you divide by a positive value, but the sign will swap, so from greater than to less than, if you divide or multiply by a negative value. If you are given an nth sequence, say n plus 4, you need to be able to find any sequence in this term. So when n is 6, n plus 4 is going to equal 10, and when n is 100, it is going to equal 104. Now, slightly more complicated than that is doing it reverse, finding the nth term from a sequence. The first thing you need to do is to work out the differences. So between 1 and 5, it is plus 4. Between 5 and 9, it is plus 4. And between 9 and 13, it is plus 4. Telling us the first part is going to be 4n. Now we can actually work out what 4n is. So if n would equal 1, 4n would equal 4. If n was 2 for the second term, 4n would be 8. If n was 3, 4n would be 12. If n was 4, 4n would be 16. Now we can work out the difference between what the term would be if it was 4n. So this is 4n, and now we're going to work out the difference. So 4 minus 1 is 3, 8 minus 5 is 3, 12 minus 9 is 3, 16 minus 13 is 3. That gives us the second part, which is minus 3. 4n minus 3. Your square numbers, cube numbers and triangular numbers are going to come up a lot, so it is worth recognising them at least, but preferably what I would like you to do is try and learn as many as you can. For your square numbers, that is 1 to 13, 15 and 20. So 1 to 13, 15 and 20. They will speed things up if you can recognise those, as many cube numbers as you can and as many triangular numbers as you can. You can see over here that I've made you a video going through all of these. You can, flashcards are a great thing to do, or you can go to my website and download the ready-made set of flashcards to speed things up. Foundation 2 students, well done, you have finished this section. You can go on to do another section or go on and test yourself with some past papers, or go through the revision guide and work out which bits you need to work on, which bits you're okay on. Higher 2 students, I'm afraid we still have quite a lot left to do. Putting fractions in things sometimes freaks people out, but there's no reason why it should do that. You can either work with the fractions as they are and simplify it, or you can get rid of the fractions. And the easiest way to get rid of the fractions here is to times everything by 4. So a half times 4 is going to give us 2x, 3/4 times 4 is going to give us 3, and then 1/4 times 4 is going to give us 1. Now it's an easy one to solve. You could just leave them as they are and solve it like that. So we are going to have a half x equals a quarter minus 3/4, that's minus a half, so x is going to equal minus 1. Let's just check the other side. Moving 3 over, we're going to get 2x equals minus 2, so x equals minus 1. Slightly more complicated quadratic to factorise now. Still going to start in the same way by drawing down our double brackets. 2x has to go in one of these because the only thing that times is to make 2 is 1 and 2, so one of them has to be 1, one of them has to be 2. If it was 4x, it would be slightly more complicated because it could be 2x and 2x, or it could be 4x and 1x. Now remember, we need to have things that multiply to make this, and add to make this one. So things that multiply to make 6 are 3 and 2, 1 and 6, but you'll notice it is minus 6, so that is a bit more complicated. So it could be minus 3 and plus 2, or it could be plus 3 and minus 2, so minus 1 and plus 6, or plus 1 and minus 6. But because we also have the B2 in front there, we don't know which way round they go, and this time it does matter. So it could be minus 2 and plus 3, or it could be plus 2 and minus 3, or it could be minus 6 and plus 1, or it could be plus 6 and minus 1. So we actually have quite a lot of combinations to go through here. Now we need it somehow in combination with 2 to add to make 6. And then looking at this initially, if it wasn't a slightly more complicated quadratic, you would initially assume it's this one because these ones easily combine to give plus 1. But we have to take into account that one of these numbers is going to be multiplied by 2. So you need to do a little bit of trial and error, you need to do a little bit of thinking, and with our thinking, even if one of these numbers was times by 2, there was no way we could make it add to make 1. So we can discount all of those probabilities at the beginning. Now, what you need to do is to put a few things in and try and work it out. Now, we know one of these has to be times by 2. However, if we times the 3 by 2, that's going to give us 6. And there's nothing we can do to 6 and 2 to make it equal plus 1. If we times the 2 by 2, that gives us 4. 4 and 3, we can combine to give us plus 1. So, from that, we can assume that it has to be the 2 that is times by 2 and the 3 that isn't times by 2. Now we just need to work out where our pluses and our minuses go. We need to come up with plus 1, so we're going to have plus 2 times by 2 giving us plus 4 minus 3. These can seem quite complicated if you go through and do every single possibility by trial and error. That will take you quite a long time, but if you just sit, think and try and apply a bit of logic before you start with a trial and error, that should narrow down the number of things that you have to try. Algebraic proofs can seem complicated, but it is just the application of logic and algebra together. There are a few shorthands that you need to know to make your life easier. If you need to have an even number, it is 2n, because even if n is an odd number, say 3 times by 2, 6, that is an even number. If you want something that is an odd number, you can do 2n minus 1, because an even number minus 1 or plus 1 is going to be an odd number. If you have consecutive numbers, you can have n plus 1, and n plus 2, and if you need to prove something is a multiple of something else, what you need to be thinking about is factorising. So if you need to prove something is a multiple of 6, then you can take whatever it is, and as long as you can divide 6 out of it, then you've proved it's a multiple of 6. Inverse functions may seem complicated, but they're not. You need to do take your function and then think about what you've done, do it backwards and do the opposite. So with 3x plus 2, you would times by 3 and then add 2. If we want to find the inverse function of this, you would need to do it backwards. So you would need to do the opposite, but going backwards. So instead of adding 2 last, we would minus 2 first. And then instead of timesing by 3 first, we would divide by 3 last. So what we are going to get is x minus 2 over 3. Composite functions are combining two functions at once, and what you need to do is look at the one that is closest. So we need to do g to x first, and then once we've got our answer, we need to put it back into f. So if we put x into g, we are going to come up with 2x plus 1. So then we need to put that into f in place of x. So where we're going to get 3, and instead of writing x, I'm going to write my answer from g, which is 2x plus 1 plus 2. Now we just need to multiply out the brackets. So 3 times 2x gives us 6x plus 3 plus 2. So that is 6x plus 5. If A and B are perpendicular lines on the graph, then the gradient of A and the gradient of B together are going to equal minus 1. For example, if the gradient of A was a half, we knew that if they were perpendicular, it would have to equal minus 1. So we're trying to find the gradient of B. What we would need to do is to rearrange the equation. So B equals minus 1 over half. So that's going to give us minus 2. The turning point on a graph is the bit down here where the gradient changes. Now you need to rearrange your quadratic equation so it looks like this as a formula. Then we can say that x plus a squared minus b equals 0. And note, even though I've used a and b here, these do not necessarily mean these are the same values. Once you've got that, you can just rearrange it to find what x is going to be. And once you have x, you can then find y. The graph of y equals 2 to x will look like this. The graph of y equals half to the x will look like this, both of those passing at 1. You need to recognise the sine, cos and tan graphs. So your sine graph is going to start at 0, it's going to go up, peak at 90, back through 0 at 180, down to minus 1 at 270, again through 0 at 360, peaking at 1 at 450, and then back down to 0 at 540. Your cos graph looks very similar but is shifted over slightly. So at 0 we're going to be at 1, and then going through going through 0 at 90, down to minus 1 at 180, back up to 0 at 270, 1 at 360, 0 at 450, and then minus 1 at 540. Your tan graph does look quite different though. So starting at 1, we go up, and then we go just past 90, ever so slightly just past 90. We're back down again, 0 at 180, and then these are going to touch either side of the 270 and 450 lines. This is just combining things that we know about functions and things that we know about graphs. So instead of just looking at the function as algebra, if we sketch it graphically, you should be able to sketch both of these graphs, x squared and gx equals 4x minus 5, and then think about the things that you're used to doing to graphs. So making them wider, making them narrower for quadratic graphs, moving them up, down, left or right. So this isn't anything new here. This is just combining two slightly different things together in one question. Sometimes in math they need you to be very accurate and specific, and sometimes they just want you to estimate an answer. So if you want to work out the gradient of graph because it's telling us something, like in this instance the gradient of a velocity time graph is the acceleration. If we wanted to be exact and we had a straight line, we could look at the change in velocity over the change in time. However, here we don't have a straight line, we have a curved line. So if we just want an estimate, say over the first minute, we can just look at the points where it ended up, where it started, and use those points, assuming it is a straight line, to then work out the change in velocity, change in time, and to work out the acceleration. This will not give you an exact answer, so if the question says calculate, this is not what you do. This is what you do if the question is asking for an average or if the question is asking for an estimate. To work out the distance travelled from a velocity time graph, we need to work out the area under a graph. Now, the best way to do this is to divide this up into sections like this. This is section A, B, C, and D. Now, oops, another section in there. Sneaky, we'll call that B dash. Every time that you see a change in velocity or a change in the graph, put in another section. Now, to work out the area of A, it is just the area of a triangle. Area of B is the area of a rectangle. B dash, you'll notice we have a rectangle here with a triangle sitting on top of it. Area C is just a rectangle, whereas with D, again, we have a rectangle with a triangle sitting on top of it. Then add those all together and you'll have the distance travelled. From a distance time graph, working out the distance travelled is just going to be reading it off the axis here. Working out the speed is going to be the distance divided by the time. So it might just ask you for a section or it might ask you for the whole thing. From a velocity time graph, if you want to work out the distance, that is the area under the graph. The speed, you are just reading off here. The only difference between speed and velocity is that velocity has a direction. We need to combine quite a lot to find the equation of a tangent from the equation of a circle. First thing that we know is that the tangent is perpendicular radius. So if we times the gradient of the radius by the gradient of the tangent, we should get -1. To find the gradient of the radius, you can just turn it into a right angled triangle, work out up, which is the y of the point minus y of the centre, divided by the across, x point, x centre. That will give you the gradient. Pop it back into this equation, make it equal to -1, and from that you can work out the gradient of the tangent. You can then use the equation y minus the y coordinate that we have from our point equals our gradient, which we've just worked out up here, times x minus the x coordinate that we have from our point to find the equation of the tangent. If we are solving quadratic equations by completing the square, we are forcing our quadratic equation into something that looks like this. Now, if we think back to multiplying out brackets, this number here times this number here is going to come up with our x. So that is going to tell us what this value here has to be. So for this, we only need one bracket, and if we are going to get something plus something, which are going to be the same thing, equaling 6x, it has to be x plus 3 squared inside the brackets. Now what we can do is multiply out x plus 3, so that is going to give us x squared plus 6x plus 9. You can see we don't actually want plus 9 here, we want plus 7. So to get from plus 9 to plus 7, we minus 2. So our answer is going to be x plus 3 squared minus 2. If you're going to solve an equation using iteration, this is just a slightly more sophisticated method than trial and error. So you're generally given an equation, you're generally given a clue as to where to start, or you're told that your solution lies between two values. You need to be logical, you need to be methodical, you need to explain what you're doing to the examiners, otherwise they'll get lost. So start with the values that they give you, work out what the answer is going to be in here, and then write whether it is too big, too small, whether you're close, and then maybe go up in little bits. You might have to make a big jump, you might have to make a teeny tiny jump, but it's all about making small jumps, commenting on your small jumps, letting the examiner know your logic so that you can work out what the answer, the closest answer you can get, is going to be. Solving linear inequalities using a graph is very similar to solving equations using graph. Instead of set for a point, you're going to have a whole area that fulfills your results. So here is my inequality, and you need to work out which area of the graph is going to fill your results. What you might get is a second line on there as well, and you'll be looking for the areas that overlap. So say this area and this area, so this area here would fulfill the answer for both inequalities. Last bit here for higher tier algebra, quadratic nth sequences. So very similar to our previous sequences. First thing we need to do is start working out the difference. There we have 13, 44 minus 25 is 19, 69 minus 44 is 25, 100 minus 69 is 31. They are not the same like we would expect in a non-quadratic nth term, so we need to work out the differences again. 19 minus 13 is 6, 25 minus 19 is 6, 31 minus 25 is 6. So we've had to go down 2 layers. That tells us it's n squared. The difference between these is 6 because it's n squared. We need to divide that by 2, so that gives us 3n squared. Now we need to work out what 3n squared is. If n was 1, 2, 3, 4, 5. So 1 squared times 3 is 3. 2 squared is 4 times 3 is 12. 3 squared is 9 times 3 gives us 27. 4 squared is 16 times 3 gives us 48. 5 squared is 25 times 3 gives us 75. And then we need to work out what the original value minus 3n is. Let me just shift that up there a little bit. So original minus 3n squared gives us, so 12 take away 3 is 9, 25 take away 12, 13, 44 take away 27 is 17, 69 minus 44 is 21, and 100 minus 75 is 25. Now we can do the same, work out the differences between them. So 13 minus 9 is 4, 17 minus 13 is 4, 21 minus 17 is 4, 25 minus 21 is 4. So that will give us plus 4n. Now we need to work out what 3n squared plus 4n is, which will give us values of 7, 20, 39, 64 and 95, and what we need to do is original minus 3n squared plus 4n, and for every single one of those we get a difference of 5. So this tells us our total term is 3n squared plus 4n plus 5. Well done for making it to the end of this video. This was quite a lot in there, but we need to be realistic. If this is the only revision you've done for your GCSE, you are not going to be getting the top grades just by watching one short video. The only way you're going to get a decent grade in your GCSE maths is by practicing. Now I've done loads and loads of videos for you. Loads of exam paper walkthroughs, grade 9 booster playlist. It is all there, you just need to go and find it. If you want to get that top grade, unfortunately, just watching this video isn't going to be enough.